Okay, hello. I'm gonna present Archimedes seminar for block 2, and this is gonna be about Pollard's p-1 factorization method. Uh, so let's go. First off, we're gonna do a short recap of the Euler-Fermat theorem, because it's crucial to know about if we're gonna do the Pollard's p-1 factorization method. And we're also gonna do an example in the end, so we actually know how to do it. So to start off with, we're gonna do the Euler-Fermat theorem, which goes like this. Suppose P and Q are prime, and N equals P times Q. EFT guarantees that for any value A co-prime to P, suppose P minus 1 is a factor of some integer L, then L equals P minus 1 times K. Thus, A to the power of L is congruent with A to the power of P minus 1 to the power of K mod P. Same as A congruent to 1 mod P. Because P is a factor of N, the GCD of A to the power of L minus 1 and N will include P. So how do we calculate L? Because if A, or what am I saying? If N is not congruent to 1 modulo P, then this algorithm can't work. This is where Pollard's factorization method comes in. So for the case of N not congruent with 1 modulo P. Otherwise, we would have just used Euler-Fermat theorem. Okay, so Pollard's p-1 factorization. To start off with, we have the same thing. N equals P times Q, where P and Q are primes. We're gonna choose an integer A, co-prime to N, so still the same thing. Now we're gonna evaluate A to the power of K faculty modulo N, for K equals 1, 2, 3, and so on. We're gonna find the GCD of A to the power of K faculty minus 1 mod N and also N. So greatest common divisor of A to the power of K faculty minus 1 mod N with N. Any non-trivial GCD is a factor of N. So we're gonna look through all the steps to find a non-trivial GCD. So we're gonna look for any GCD that's not equal to 1. Okay, that's Pollard's p-1 factorization method. And now we're gonna do an example of how to do it. We start with factorization of 2747. Works for n equals p times q, where one of the two primes minus 1 has only small factors. It divides k faculty for some reasonably small k. We're gonna choose a equals 2 to evaluate a to the power of k faculty mod 2747 and then find GCD and so on. This is kinda difficult to say. The reason we choose a equals 2 is because we can see on 2747 it's a composite number of two primes, and we can see that it's not even, so a is co-prime to 2747, and it's very easy to use 2 since we're gonna work with powers, and powers of like 5 or up is kind of difficult, but with 2 it's pretty easy. So let's continue. Now we're gonna do the calculation of, if we look here, we're not gonna do the GCD yet, but a to the k faculty minus 1 modulo 2747, we can see that 2 to the power of 2 faculty is congruent with 4 of mod 2747, uh, and the answer, well, I guess 4 minus 1, yeah. Uh, so we get the answer GCD 3 with 2747 equals 1. It's a trivial answer, so we're gonna check the next value. So 2 to the power of 3 faculty, and it's still a trivial answer. We're gonna check the next one, 2 to the power of 4 faculty, and it's still trivial, so we check the next value, and here we see that the answer is non-trivial. We can see that it's 41 here, and 41 is then a factor of 2747. And this is how we use Pollard's p-1 factorization method to find one factor of a composite number. Uh, and we find the other number by just dividing by the original number. And we see in the end it's 2747 equals 41 times 67. Uh, and that's it for Pollard's p-1 factorization method. Thanks for watching.